So periodicity means something repeating after a regular interval. And we started with the periodic table after that. So in the periodic table, what is repeating? We remember we discussed the first thing, the general configuration.
It says
Yeah.
periodicity in the periodic table is based on the atomic number. Which,
That is first thing, atomic number, and then
which repeats the chemical and physical properties.
after a regular interval, right?
Yeah.
And
Yeah.
why this repetition of physical and chemical properties after a regular interval? What is repeating?
The electron configurations.
Yes, yes. And the chemical and physical property, they depend on
The
valence,
no,
valence
the
The
electrons.
valence electrons.
valence electrons.
And valence electrons are repeating after a regular interval. Like how many valence electrons in first group?
Oh, one.
One,
In second group?
two.
Like this. So all the elements of first group, though you're starting with lithium, beryllium, boron, carbon, nitrogen, neon, and after neon, you're getting sodium, and sodium has exactly same valence electrons as lithium. So elements with the same valence electrons are falling in the same family, same group, right? So it means they have nearly same chemical and physical properties because they can lose the same number of electrons here. What are they going to do? What's the general configuration? Kyra, you remember the general configuration for this one?
The general?
Yeah, this one, NS1. This you did with me. You were there in the class. Do you remember?
I don't think she was there.
Yeah, she wasn't there. I think you just.
I wasn't in the previous
Yeah.
class.
We didn't do this earlier.
No, we discussed it
we
last
just
class.
yeah, we discussed it last class.
Oh, okay. Then she needs time. Okay, fine. But she knows how to write the configuration. Okay. So very first thing what we did, Kyra, you watch the video, okay, and understand the meaning of general electron configurations. The second thing is valence electrons. Valence electrons. You know the meaning of periods and groups, all of you?
Yeah.
So valence electrons, remember I was writing as VE. Valence electrons are equal to the number of groups
Yes.
in the periodic
Yes.
table, provided
Yes.
we need some changes. What are the changes? That you are not going to consider this one and this one, right? And then you are going to number it. 1, 2, what is the next? This is 3 then.
3,
3,
4,
4, 5,
5, 6,
7,
7,
7,
8.
8.
That's the main periodic table. What are these two blocks?
S and P.
D, F.
So can I say S and P blocks are the main periodic table? Can I say that? Main periodic table. So most of the chemistry we are learning from here. S and P block. Yes, you are in trouble, Aditi.
I was just looking where. Oh, never mind. Yeah, I know they are.
This is S block. This is P block.
Yeah.
So most of the chemistry we are learning from S and P block. Why?
Because it's the main periodic table.
The main.
But
main.
why? Why it is main? Why we are learning only this? Why we are not learning D and F?
Because
DNF has more complex and more.
More complexity.
Okay. What you were saying, Avni?
I said they were more complex.
Oh no, not complex. They are more common. They are simple. These are complex. These are complex. Okay. You're not learning complex chemistry. You're learning simple chemistry first thing, right? Second thing is that they are the elements which are most common. They are the most abundant element. Please understand this. Most of the chemistry is dominated by S and P. So that's why we are learning only S and P. We are ignoring D and F. You're getting it? So please, this is very important that S and P block elements are the most abundant elements. Is it okay?
Yeah.
Most abundant means
Most like around you, like they're more like there,
they are
like in the this,
more
like
available in the
there's
nature.
more,
Yeah.
yeah.
You're right, Avni. So don't you think they are more stable also? Isn't it? They are
Yeah.
found, most abundant element means more found around, more found in nature. They are the most common element, not the complex elements. They are lighter elements, most common element. They are the most abundant element and they are the most found element in the nature. Aditi?
Oh, I was saying DNF is more complex.
You didn't say that. You said SP or DNF?
I said DNF.
Oh, we didn't hear that. But DNF, she's right, is complex. And in fact, they are rare. They are F block elements. You know what is the other name of F block elements? The other name? The other name of the F block elements is rare earth metals.
Oh yeah, it was
Rare earth
rare
metals.
earth metals. Yeah.
So you know the meaning of rare, right? Rare means not so much
like
abundant.
not
Common.
not common.
Not common. It's hard to find.
Yeah,
Hard to
it's quite,
find.
yeah,
So
hard
their
to find.
chemistry, yeah. You know, whatever book you pick up, like I'm teaching college children also, there is only hardly one chapter on F block. D block is still abundant. Copper, zinc, iron. Iron is so much around you, right? So D block elements are still not so less, but F is rare. We don't have any F block elements so easily available around us. And most of them are radioactive also. F block elements are very heavy. So we have 1 unit of radioactivity. We'll do that. We are good with this, children, till now. So we are
Yeah.
going to focus on main periodic table. We'll talk less about D and F because they are not so abundant, not so common. So valence electrons is number of groups. Okay, good. So what is the trend? Down the group. As you move, you remember I discussed that we are going to say, oh, why I'm writing ground, group. Down the group. Down means top to bottom. So this is the
Yeah.
language people are talking. When they talk about group, they say top to bottom or bottom to top. But most of the time we are saying top to bottom. Or you can say down the group. Right? See, children,
Yes.
I have posted that booklet of the, oh, okay, you were telling me that was old one, right?
Yeah, there was one from last year, but you were showing like this year one, but it's not
That's
there.
the 20th anniversary one. Yeah.
Mm-hmm. Okay, I'll share the other one. You start reading the book. I gave you on WhatsApp also. Okay. So you need not to take out the printout, just open it in your computer and read from there. Start reading it so that you understand the language also. Because in the class, most of the time I'm speaking. So my language is getting more and more refined. But you people are not speaking much. So maybe these words which are new, you need to practice. So read the book loudly, very loudly. As you were kids, your parents used to say, okay, read it loudly. Alphabets, you know how the kids they do A, B, C like this. So these are new words. So read the book loudly, okay, so that you can become familiar with these new terms, general electron configuration, valence electrons, all these things. So down the group, top to bottom, what happens to valence electrons?
It stays the same.
Yes, no change. No change. But across the period,
It changes.
Oh, across the period it changes.
across the period means left to right.
Like, yeah, left
Left.
to right.
Yeah, that's how we say
Like
across the
each.
period.
Yeah.
Left to right. It changes.
In
And how it is changing?
It changes like the
Changes
number of
by
valence
one.
electrons. It
How is it
changes
changing?
by one.
By one,
one,
yeah.
yeah.
Changes by one, yes. Changes by one. That's the trend of the valence electrons. So what is happening to the chemical nature and physical nature across the period?
It's
Uh,
changing.
It's changing. But down the group,
Down the
It's
group,
same.
it's
the
nearly
same.
same. Not
It's
exactly same.
almost the
Well,
same.
yeah.
Yeah, like the first group, these are matter, so all of them are matter. But there is a trend that I will discuss with you. Okay, so that's why I'm not talking about the chemical nature, but chemical nature is nearly same. Kyra, you have a question?
No.
No. Okay. So this is about the second one, second trend. Now I'm taking you the most important one. Before I start discussing this important trend, very important, is going to control your periodic table completely. Let's understand that. You already know that there is a nuclear charge. What is the nuclear charge? Negative or positive?
Positive.
And there is a attraction of the nucleus with the electron. What is the name of this attraction? Plus, minus. What is the name?
Magnetism.
Oh, no, no. These are charges, dear. Magnetism is a different force.
Oh, is it electromagnetism?
Electrostatic.
Oh,
Okay, so don't use word magnetism here because magnet is a different thing. If you say electromagnetism, then again magnetism word is there, Avni, right? This is electrostatic attraction. But this word is very less used. In place of this word, what we are using? Coulombic forces of attraction. Coulomb is the name of the scientist. Coulombic forces. You know, I discussed plus, minus. I told you this word coulombs
yeah.
earlier.
Yeah, you did.
Yeah. So these are called as Coulombic forces. So if somebody says, what do you mean by Coulombic forces? How you're going to answer?
How the
They're
nucleus
electromagnet.
electrons.
I'm planning to finish everything fast because after that, I want you to give practice to speak these chemistry words. You have to speak a lot, okay? So whenever I give you some new word, please speak from your side also. So what is Coulombic forces?
When the nucleus is
Nucleus
attracted
attracts
to
the
the
electrons.
electron,
They're like
Attraction
attractive
between positive and
then
negative.
Negative.
charges.
and even repulsion is also Coulombic forces. So we have Coulombic forces of attraction, Coulombic forces of repulsion. So what we can say about Coulombic forces? These are attractions or repulsion among the charges. Am I right? Attractive forces of different charges. Different means opposite charges, or these are or. So you cannot say that repulsive forces are not Coulombic. They are also Coulombic. It's the force of attraction or repulsion among the charges. Repulsive forces of same charges.
Yeah.
We are good with this? Let's talk
Yeah.
about oxygen. In oxygen, how much is the nuclear charge, Aditi?
8.
8. 8 protons, very good. Kyra, how many electrons are there?
You mean valence
Oxygen.
electron?
Oxygen. How many electrons?
8.
8, yeah. So we don't have 1 electron, we have 8 electrons, correct?
Mm.
So what are the forces which are operating inside the oxygen? Can you tell me the forces?
Plus and minus.
Plus and minus. What is this
minus.
plus and minus? Attraction?
Coulombic law. The Coulombic forces
Electrostatic.
of attraction.
Say again, Avni.
Electrostatic.
Coulombic forces of attraction.
Yes. Very good. Like this, Kyra. Okay. Use the word, because when you use the word only, then you will retain it. Right? But there's one more force. What is that? Do you think these electrons are in love with each other or they hate each other? Electrons.
They hate each other. They
Ew.
hate each other.
And they are there, plenty of them. You can see. So if
Yeah.
one electron is going closer to other electron, what will happen?
Repulsion.
Repel.
Yeah, okay. So there is electron, electron. What kind of forces are there, these?
Coulombic forces of repulsion.
Forces of repulsion.
Repulsion.
Very good. Coulombic forces of repulsion. These are the two forces which are operating inside the atom. Repulsion and attraction. Based on these repulsive and attractive forces. So first thing is that attraction is more, repulsion is less all the time. Because electrons will never face each other. They are moving continuously. They are moving so that they don't come closer to each other. So nature is managing that. So repulsion is less, attraction is more. That is the reason atom is stable. You remember this line? More attraction means?
Nature likes it more.
Yeah, what does it mean? Nature
It's
likes
more
it more.
stable. It's more stable.
Yes.
Stable.
And energy?
Low. I think.
Yes,
Low.
yes.
Low.
Yeah, less energy. And nature wants less energy,
Less
right?
energy.
Energy.
If you eat something which is very energetic, like chocolate or something, it creates a lot of energy inside you. And what happens? You will keep running. I've seen children, very young children, eating so many chocolate. Like one, it was 10, 20 years back. Some friends, they came to our house. They have a small kid, very young girl, and she was running around, tuck, 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 tuck. She was not able to sit at all. Then her mother told me she ate 2 chocolates. I said, okay, fine. Because if you are energetic, if you are full of energy, then nature will force you to work to release it. So the girl is running around to consume that extra energy due to chocolates, because nature wants her to be low in energy, right? So nature is asking her to run, run, run like this. Okay. So more attraction, more stable, less energy. So we have done 2 trends. 1, 2. I'm taking you now on the 3rd periodic trend. I'm going to erase everything. Ready, children? 3rd, size. So first thing is that we have to see down the group. Down the group.
What do you mean by size?
Size of the atom. Like, for example, this oxygen.
Oh, that makes sense.
The nucleus is very small. You remember I told you I compared the size of the nucleus like a small marble in a football ground. Nucleus is very small. Nucleus is not going to contribute anything to the size. It is exactly in the center. So size is controlled by the cloud of the electron around the nucleus. More bigger cloud, more bigger size. You're getting it?
Yeah.
Size means yes, Kyra.
Is there only like a bigger cloud when there's more shells?
Yeah, yes. See, she's starting telling me what happens down the group. So more shells means more rooms, more bigger cloud. Is she right?
Yeah.
Okay. But I will discuss this.
Yes.
So she has already started analyzing it, but we need to analyze with depth. Down the group, when I go from element 1, how many shells are there in element 1?
1,
One,
1.
One shell.
Element 2,
2 shells,
2,
3,
3,
3 shells,
4.
four,
4,
4 shells.
What is happening to the size as the shells are increasing?
they're
it's
growing
increasing.
bigger.
It's increasing the
Increasing.
numbers.
So down the
Yeah.
group,
There's
number of shells are increasing. Can I write that?
Yeah.
yeah.
Number of shells are increasing. I was just thinking about one more point. So because you girls are very smart, so I'm taking you more in depth. Number of shells are increasing. First thing. I'm introducing you with something which is only for very high level chemistry students. Let me see if you can understand. It's not tough. Nothing is tough, right? Let's see. I'm making this picture again. This one. Let's talk about hydrogen. This is the nucleus. And I'm making this electron cloud here. How many electrons are there in hydrogen?
1,
And 1.
Is there anything between this one electron and the nucleus? Anything in between?
no,
Nothing.
No.
So can I
No.
say this
Nothing.
electron is completely exposed to the nuclear charge? No one is in between? You know, when you are going for a kind of stage show, this is the stage, right? And you always run to go in front because you don't want people to come in between the stage and you. You want to say
Yeah.
it more nicely. So if you are here
Mm.
and there are tall people in front of you, so they are going to screen the stage, screening, right? You won't be able to see it. You have to go high on, you have to sit on some high chair or at some height to see what is happening on the stage, right?
yeah,
So if more and more people are there in between you and the stage, then the stage is more screened. Screen means shielded. There is more screening between you and the stage. So I'm using this word here. With hydrogen, there is no screening. The nuclear charge is completely exposed to this electron because there is no one in between. But if I go to lithium, this is lithium. How many shells are there?
2,
So one
2,
shell,
2.
and then second shell. Do you think there is no electron between the second? There are electrons here, right? There are
yeah,
electrons here, 2 electrons here and 1 here. So what about this electron? Is it completely exposed or there is someone else screening it from the
someone else,
nucleus?
Someone else.
screening.
Who is screening?
The 2
he's
other electrons,
Yes, if I go to cesium, look at the cesium. I'm making is different shells with different colors. So this is shell number 1 for cesium. And then this is shell number 2 for cesium. Then this is shell number 3, right? And shell number 4, shell number 5, and shell number 6. I'm making 6 here. Now let's talk about this electron. There's one electron here. Now, and nucleus is in the center, nuclear charge. Is the screening more or less?
More.
More.
Much
More.
more, right? Now answer my question. You can see 3 examples: hydrogen, lithium, cesium. In which case the outermost electron is more shielded from the nuclear charge,
In cesium,
Cesium.
and in which case it is totally exposed and not shielded at all?
Hydrogen.
hydrogen,
Hydrogen.
I'm using a new word, shielding. This is called a shielding effect. So what happens to the shielding effect down the group?
it increases
It increases
Why?
because there's more shells and more
there's
electrons.
Because
One
when there's
cell?
more shells,
Yeah.
that means there's more electrons surrounding it.
The nucleus. So the outermost electron cannot feel the nuclear charge so much. This is called as experiencing the nuclear charge. It's not going to experience full nuclear charge, right? So shielding effect increasing because of the more number of shells. Remember this, more number of shells. So these are the 2 factors which you have to understand down the group. Now, based on these 2 factors, especially the second factor, can you tell me what is happening to the attraction of the electron with the nucleus as the shielding effect is more?
It decreases
It decreases. Why?
because there's more electrons in the way to stop the effect. So even
Yeah.
if it were to attract, it'll be repelled by the other electron before it could get to the nucleus.
Wow. So what will happen? That's very good. Avni didn't miss even a single word. So children speak scientific language now. She is doing that. So she said, okay, that because there are so many electrons in between, so it cannot experience the nuclear charge. And if it tries to penetrate, this is called as penetration. The clouds can penetrate, they can go inside. They will try to penetrate to get more and more positive charge. Like this is something like food, right? And this is a hungry man. And this is the other population surrounding the food. So what the hungry man is going to do, it will try to penetrate, right? But more it is shielded, lesser food it will get. But here she used a very good word that electrons have the negative charge. These electrons are also negatively charged. So this negative will repel also. So what happens? Expansion. The outermost shell will go more away. Am I right? Because nuclear charge is less. So it is going to go more away to minimize the repulsion also. Is it difficult, Aditi?
a little bit confusing.
Okay, you ask your questions. Kyra, questions, please.
I don't have any.
Are you thinking or not thinking? See, I'll say Avni and she's going to throw a question. Avni, throw a question.
I do have a question, but it's not actually related to the shielding effect. It's actually related to the neutrons in this case.
New terms.
Neutrons.
Neutrons. Okay, neutrons. Yeah, what is it?
I actually don't think this is really related, but I was just wondering, in hydrogen, you have 0.01 neutrons. How is that possible?
Oh, this question you asked last time also. Am I right? Or maybe there was another student and I was really surprised. You know why she's saying that? Because she is looking at the atomic mass here. But dear, this is not the real atomic mass. This is average. Average atomic mass. Don't
But even
calculate your...
even if it's average, though, I mean, you round it to something that's, bigger or smaller. So what you're saying is that this number is even more complicated. I'm not quite understanding how that's changing the fact that there's like a decimal value of a neutron.
There is no decimal value of neutron. Okay, let's see. In your class, there is a student who is 15-year-old. The another student is 16-year-old. And the other student is 13-year-old. Right? How many students are there?
3.
3. So what is the average age of the class?
Mm,
15 plus 16 plus 13 divided by 3.
3.
How much is this? No one else is doing? Aditi, this is your question.
44.
Uh-huh.
44.
No, 44 divided by 3.
Oh, wait.
Right? 44
Oh,
divided by 3. So 1,
14 and 2/3, I think.
14 point something.
14
14
point.
and
But how
2/3.
come you are getting this
14 and
point?
2/3.
How you are getting this point? Because you are taking average, right? Like if I say there are 15 marbles, you know, marble which we use for playing games, 15 marbles. Avni has 15 marbles and Aditi has 16 and Kyra has 13. So I'll ask them, okay, put all the marbles here. I'll give you equally. So you are going to put all of them together. But now how many marbles I can give to every one of you? 14 point something.
14.
Point something.
Oh, but you can't
I
have
cannot
like
do. I cannot do. So
point
I'll give
something
one
in it.
extra. Yeah, I'll give one extra to someone, whoever is dear to me. Right? That will get one extra.
So you need to don't you need to find like the exact number? Like in this case, I know for like the marbles, you can't just like split them in half. Like
Yeah,
when you're trying
yeah,
to find
exactly
the
in the same
average, it
way.
has to be.
Yeah, average can be in fractions. That's what I'm trying
To
to tell you.
round
Avni.
it.
Average can be in fraction, but it doesn't mean that your neutron is halved. Because hydrogen has 3 isotopes. You have not done this topic. I'm going to do this very soon. It has 3 isotopes. Just like 3 ages in a class. One has a mass of 1, other has a 2, other one has 3. And then they are doing average of all these 3. And depending upon how many. So it's a big thing, average atomic mass. In the periodic table, the masses are in fractions. So please write down. In the periodic table, the masses are in fractions because they are average atomic masses of isotopes of the element. Because Avni asked this question, that's why I'm giving you this answer. Otherwise, the topic is not done yet. We have to do it. It's a very important topic. So the question was very, very important. That why the atomic mass of hydrogen is 1.01. Does it mean neutron is in fraction? No, not at all. It is the average of these 3 isotopes. Is it okay, Avni?
Yeah.
So please remind me about this when I'm going to do some more about atomic structure. So can I come
Okay.
back to the periodic trends?
Yeah.
Okay, can I say that as the shielding effect increases, the nuclear charge felt by the electrons decreases and the size increases? Can I say that?
Yeah.
Kyra, you're not listening. Are you okay, Kyra? You are very sad today.
No, it's just regular. I'm just kind of tired.
Oh, you're tired or you're still thinking about your party? Hmm? No? Candies, parties? You know, generally, when we are very excited, very happy, the next day will be we are very down. Generally, it happens, isn't it? Stay happy every day. Every day is a party, okay? Take every day as a party. So right now we are doing party with the shielding effect. Shielding effect. So what is happening to shielding effect down the group? Increasing.
Increasing more number
What
of
is happening to
shells.
number of shells? Increasing.
Increasing.
Due to
Increasing.
these two factors, what happens to atomic size?
Increasing.
Yeah, size increases. Is it okay? Size is increasing down the group. If somebody asks you, what are the two reasons?
Oh, the number of shells are increasing, and then the shielding effect. More number.
Children, your parents are available this Sunday?
Sunday.
Um,
I
what
think
time?
depends on the time.
Yeah, it depends on the time.
Depends. Yeah, it depends.
No, not Sunday morning, evening. I'm busy. Sunday, yeah, Sunday evening. Are they available around this time?
I don't
No.
we have something.
I'm
Okay,
not
what
We
about
have a
most
Saturday
likely
morning?
not.
Saturday morning?
Saturday
Oh
morning.
no, I'm gonna be really
There
busy.
my mom's available, but not like after 10 or like at 10, before 10.
Oh, okay.
Sunday
Then
morning.
can you
I mean
just
Saturday
request
morning.
your parents to pick up a time at which I'm also available? So I'm available every morning, but not on Saturday morning, just for a discussion online about you people and how to uh, go about YBTC exam, because I know that they are thinking about it, right? So if we can sit together and discuss about it. So if your
Okay.
parents can think about of some time, mornings are okay with me, not evenings.
Okay.
Okay. Your mornings, not my evenings. I'm totally busy with the classes. So please convey this to them.
So our evenings or our mornings?
Your mornings.
Okay.
Size is okay? Down the group increasing?
Yeah.
Okay.
Yeah.
I'm going
Wait.
to, yeah.
Our mornings you're free.
Your morning, any day except this
okay.
Sunday.
Mhm.
Yes. Yes, Kyra.
So I have a question about like shells. Like are shells like when you look through like a microscope or whatever you look through to look at an atom, then will you actually see like an actual shell or will it be like invisible?
No, no. Okay, yeah, that's a very good
I
question.
don't think we can see atoms as of now.
Cannot see, but she's talking about looking through a electron microscope, something like that.
Yeah, something.
Oh, people are doing
you
that.
can see it like clearly. Like
Yeah,
would
we
it be
can see.
invisible?
See, we have very big equipments. We can approximately we can see how it is, but electrons you cannot see. But and remember one more thing: shells are
Wait,
not boundaries. Like you cannot say that okay, this is the nucleus. Now this is one room. These are not walls. There are no walls. This is wrong representation. But we are doing it to understand. So what is the right representation? This one. Can you see I didn't make any wall? It's the space around the nucleus where the electron is moving. Isn't it? So shell is not a boundary. Shell is not a concrete wall. Shell is that whatever space that electron is occupying while moving, that is shell. Is it okay, Kyra? But can you see electron? No. But when we take the picture of the atom, then we get diffuse cloud like this. Why? Because the speed of electron is very, very high. Let's say you are clicking your picture. When you are clicking your picture, people will say, okay, stand still. Why? Because when you move, picture becomes blurred. You have seen blurred pictures.
Yeah.
So Electron is continuously moving with very great speed. Speed is so high that you cannot think about it. So by the time you click the picture, electron has moved that place many times. So that's why you see this kind of cloud. So it is represented by a cloud, and this is the shell. There is no
I
boundary.
have a
Mhm,
question. So you know how like the atoms bond and all that stuff, right? With their electrons.
mhm.
So if they can gain or lose electrons and it's like really easy to get the electrons, then how come people can't just like somehow make like some sort of attraction thing and attract the electron out of it so it's not moving that fast and then just look at it using a very strong microscope?
Yeah, I think this is how they are doing, Avni. You're right. So they are trying to use atom at very low temperature, very low temperature, will reduce the speed also. So people are using all these tricks, what you are saying. So when you go in and work in the lab, big knowledge, big formulas, big mathematics, they are less important than these basic knowledge, basic understanding, because lab is doing experiment, working with nature. What is a lab? That you are trying to do something in nature, which is controlled by nature also. So you can do the changes according to your requirement, right?
And I
So
also had one more question. um So if the electrons are moving so fast, then how is it possible to see the protons and neutrons? Because you said that we can't see electrons, so that means we can see protons and neutrons. But if the electrons are moving so fast around them, then how come we can see them? And it's like and I think you said that it was like nearly impossible to like break a proton from a neutron and things like that. So how is it possible?
protons and neutrons are inside the nucleus and they are bigger than electron. They are heavier than electron and they are compact here. They are present in very small, it's a dense area, very dense. Which part of the atom has the highest density? The nucleus.
Yes,
Yes.
but
The nucleus.
I'm still I still have the question because, like, for example, like if I have, it's like this, right? This is the nucleus, and then if I'm having these electrons go like this, then how is it possible? Because it's like it's a blur that's covering up the protons and neutrons.
Yes, blood, but that's not very dense, right? Electrons, how many, if let's say my shell is 1s2, two electrons only. So
Yeah.
now these two electrons are moving very fast around the nucleus, making a cloud of electrons. When I click the picture, it's blood picture, right? So that blood picture, do you think is going to cover the nucleus completely? No, because
No.
nucleus is the most densest part of the atom. Rest is just moving and it's not so dense. So you can see from the less dense, the more dense thing is visible to us.
So wait, so I understood that, but can you see like the protons and neutrons of this element then? Because if it has 108, oh, wait, yeah, actually, never mind. I understood now. It has 108 neutrons as well, protons. So, yeah, okay, I understood.
It's very big, right?
Yeah.
Okay. So there are many new techniques are coming. So we'll discuss these things once I will come back to atomic structure. Atomic structure will come back again. I have to discuss isotopes. So are we okay? Size down the group? We are okay?
Yeah.
Okay.
Yeah.
Now, Kyra, give two reasons why size down the group increasing.
The size down the group increases because one, when you like go down the group, there's more shells that comes,
Mm-hmm.
and then because the shielding as well,
Yeah,
and
you
then
can read also. I want you to speak this word.
when the shielding effect increases, then there's
Why the shielding effect
um,
is increasing?
because when there's more shells, then what happens is then more electrons are crowded around the nucleus,
Yeah.
and the valence electron can't really, it doesn't attract
Experience.
that much to the
Yes.
nucleus anymore because the other electrons they repel
Screen.
against the electron, so it makes it more harder to
Experience the charge. Yeah. 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 Okay. Aditi, can you speak this word? Speak this word. Aditi,
One.
what is written here?
Oh, shielding effect.
Yeah. What you were thinking, Aditi? Okay.
Yeah.
She was thinking I'm asking a tough question. Okay. So children, why I'm saying this? Because I want you to become familiar with the words, speak them. Any new word, please speak about it. So we are talking about size. So we just discussed down the group and we have seen two reasons. Let's go across the period. Slightly difficult to understand. We'll try our best to understand in one go. Okay. So pay attention. Across the period.
Oh, are you talking about the NS?
No, across the period, we are talking about size. See,
Oh,
size,
okay.
third trend size. We are talking about
Oh,
size only.
okay.
So what happens to the
Yeah.
size across the period? Let's see these two factors across the period, children. These two factors. What is happening to the number of shells across the period?
It's increasing.
Avni, what did you say?
I said it stays the same across.
Okay, now Aditi, what did you say?
Increasing.
Why? Period number 2, how many shells? Period number 2 has how many shells? 2 only.
Oh, two.
See, that period number indicates the number of shells. Period number 3, how many shells across the period? 3 only. So stays the same. Write down this, Aditi. Do you know the reason now? You write the configuration. Period number 2 is 1s2, then 2s2, 2p6. So there are only 2 shells, 1 and 2. The complete period has only 2 shells. Complete third period has only 3 shells. So number of shells stays the same. Is it okay? What happens to shielding effect?
It stays the same
The
Why?
shielding effect stays.
because the number of shells and electrons is also the same.
So what you have taken today? You are very smart today, Avni? She gave the answer very smartly. She said shielding effect stays the same, no change. And she gave the reason also very accurately because shielding effect is by the more number of shells. If number of shells are not changing, then shielding effect is not changing. Avni, very good. Aditi, Kyra, are you okay with this concept?
Yeah.
Yeah.
Aditi, this is clear that why she said that shielding effect stays the same. Aditi, answer
Oh,
it.
yeah.
Okay, okay. So because number of shells are not changing, so that is the reason shielding effect is also not changing. Both of them, because shielding will be the same. What is the shielding in lithium? Lithium has this is the nucleus, and there is shell number 1 with 2 electrons, and this is outermost shell with 1 electron. So how many electrons are shielding it?
2.
2. How many electrons beryllium is getting shielded? With again
2.
2. Boron with again 2.
2.
Carbon with again 2, like this,
2.
right? So the shielding effect across the period is not changing because number of shells, the shielding is 2, 2 for the second period. For the third period is going to be 8, 8. So what is changing then? How to compare the size? What is changing? Because we have to think about the attraction, right? More attraction, more smaller the size. So what is changing? Is there anything changing? Think.
There's more
The
valence
number of
electrons. The number of
electrons.
valence electrons is
Yeah.
greater, so like
Yeah, there's more electrons
there's
trying to get
more electrons trying to attract to the nucleus.
Is the nuclear charge increasing? Yes or no? Look at the
No.
periodic table.
Mm,
Nuclear charge. What is nuclear charge?
Oh yeah,
Like
the nuclear
electrons.
charge is increasing.
yeah.
And that's the reason. Because all other reasons are flat. So now I'm left with only one factor, that is the nuclear charge. Nuclear number of protons, see? Lithium has 3, beryllium has 4, carbon has 6, like this, right? So the nuclear charge across the period is increasing. Nuclear charge is increasing. I didn't consider this factor down the group. Down the group also nuclear charge increasing. Can you see 1, 3, 11? But I didn't discuss that here at all. I didn't consider it. Why? Because major factors were shells and shielding effect. So they were controlling everything. So I didn't discuss nuclear charge down the group. I didn't touch that topic. I just said, okay, number of shells are increasing, shielding effect is increasing. So nuclear charge is effective nuclear charge. The charge felt by electrons is decreasing. That's what we decided, right? But here,
I have a question.
Mhm.
So, like, if you take neon, for example, it has 2 electrons in the first shell and then 8 electrons in the second shell, right? So, so if it's 2 electrons in the first shell and 8 electrons in the second shell, then shouldn't the 8 electrons be able to cross because, like, or penetrate because if it's 8 electrons versus 2 electrons, the 2 electrons should move away from the 8 electrons because the 8 electrons are more, so their like charge is also more. So shouldn't they move away and then the 8 electrons can get through?
Okay, she is saying that the crowd is going to kick out the 2 electrons. The more electrons, more it will be closer to the nucleus. That's what you are saying.
Yeah, because like
But the
the
problem
repulsion is
is,
more.
the problem is the first 2 electrons which you are talking, she's talking about neon. She's saying it has 1s2, 2s2, 2p6. And she's saying these 8 electrons should go more closer to the nucleus because they are more. But I'm saying no, it is not possible. Why? Because this is the sun, this is the Mercury, this is the Earth, Venus, Jupiter, like this. Jupiter is very heavy, more heavier. So why Jupiter is not going more closer to the sun? Because they are moving on the fixed paths, right? And you can compare your atom like solar system. It's not exactly solar system, it's like that. So the electrons which are in the first shell, they they are more closer to the nucleus and they have less energy. So these electrons, they will not penetrate them. They are in second shell. Second shell electrons cannot go in the first shell like this. There is a difference in energy here. First shell, number 1, n is 1. The number of electrons here are 2, and shell number is 1, is closest to the nucleus, it has lowest energy. Shell number 2 has different energy. Shell number 3 has different energy. That's why. Avni?
But so but then I thought you said that they can also penetrate, and also if like in real life, if there's like 2 people fighting, let's say, the person with more energy will beat the person that has less energy, even though nature likes less energy. So even though that's the case, shouldn't these guys still be able to penetrate?
Okay. Now, which fight you are talking about? The fight of attraction?
Like in general, like in real life, if like 2 people
Okay,
were fighting.
yeah, the 2 people are fighting. Now let's compare the fight she is saying with attraction. Here, So which one has higher attraction, 1s or 2s? The one which is low in energy. Lesser energy means more attraction, right?
Yeah.
So it means these 1s electrons have more tendency to go inside. They have more tendency to penetrate because they have less energy, right? Because of their distance from the nucleus. They are very close to the nucleus. They have very strong attraction. And 2s and 2p, they have high energy. So high energy means they are repelling more, attracting less. So they cannot go so much closer to the nucleus. Is it okay?
Yeah. And also, while you were talking, I just realized something that,
Mhm.
like a general question, like, is there some sort of formula to calculate, like for example, like when you have this 1s2 and then this. So, is there some like formula? So you said that 1s2 has low energy, which means it has more attraction, and you said that the 2s2 2p6 has high energy, which means low attraction.
As compared
So
to 1s2.
yeah, so just estimating. So I'm just guessing that this attraction is equal to this attraction, right? So is there some formula, like, or like, is there like some like, I'm just seeing if my guess is correct that because it's like low energy, but and this is high energy but more in number. Will they be equal in attraction levels or no?
Oh, so you're talking about, again, you're back to the same thing which you asked in a different language earlier. She's again asking that if there are more electrons, they should have more attraction, right? You're back to
No,
the
I'm
same thing.
saying no. I'm just saying that I know this one has low energy, so it has more attraction, but it's less in numbers. And the other one has high in numbers, but also high in energy, which means its attraction is low. So are there both attraction levels equal now? Because
No, 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 they are
one
not
is
equal. They are not equal. They are two different levels. Level number one has more attraction, so it is lesser in energy. So if their attractions are equal, then they will stay together. Why they are different then? They don't have, you are not going to combine all the attraction here of all the 8 electrons. Talk about one electron in shell number one electron in shell number two. Compare their attraction. Shell number one has more attraction, shell number two has less attraction. So don't combine all the attractions here. Okay. So I will
okay.
see what I can do to make it more clear in the next class. Let me finish this. So what is nuclear charge is increasing across the period, right?
Yeah.
So as nuclear charge increases, what happens to the attraction? Like here, see,
The
this
It also
is
attraction increases.
increases. As
Yeah.
attraction increases, what happens to the size?
It also increases.
Gets big. It
It
also
grows
increases.
bigger.
Yeah, it gets.
My girls.
Oh, if attraction increases, it becomes smaller because it wants to come more closer.
Yeah. Like for example, if you
Oh,
have this lithium has only 3 protons. Beryllium has 4 protons. Number of shells are same. Boron has 5 protons. As the number of protons increases, attraction between the outermost shell and the nucleus increases. So the the electron cloud will start shrinking. The size will decrease. See, it will shrink like this. Shell number are still same. It will shrink more. It will shrink more as the nuclear charge increases. So what is happening to the atomic size across the period? Shrinking.
It
They're
decreases
shrinking.
shrinking.
Yeah, decreasing. Why it is decreasing?
Decreases.
because the
Because
nuclear
the
charge is
traction
more,
is
so
more.
the
The
attraction is more,
traction is
so it
more.
becomes more compact.
And why this number 1 and 2 are not valid?
Which one and two?
Yeah, number of shells
Mm,
and shielding effect.
Oh,
We are not taking them into account because they are same. Throughout the period, they are same. right? So that is the reason nuclear charge becomes the dominating factor controlling the size of the atom. Is it okay?
Yeah.
Okay. So please write down that we are doing periodic trends. These are periodic. Periodic means in the periodic table, the things which are repeating in a regular manner. So we are discussing that size is increasing down the group, decreasing across the period. Please write down the reasons also. My hospital visit is there today also. Just after your class, I'm going. And this is the last, hopefully. So now I will be more free throughout the week from last 15 days. Actually, children, I was like not well in 2006. Very badly, I was down. And I was admitted in the hospital for many months. Many surgeries were done. So that is the reason my medical reviews are lengthier. So they check everything. They do PET scan, X-rays, MRI, and they want to be very sure that everything is going well. So that is the reason when my medical reviews start, I'm in trouble all the time because I don't get time for rest of the things. But today is last and hopefully this should be the last. After that, I will be uploading your homework, everything regularly. So come on track, children, now. Okay? If you want to do YBTC. Let's focus on YBTC. Once we have decided, we have decided. Okay? And we are going to win it. Am I right? So I'll show you, I'll see you in the next class and I'll give you the homework. This week, you will get the homework. On Saturday, Sunday, try to finish it. See you then.
Thank you.
Bye-bye.
Okay.
See you then.
Bye.
Bye-bye. Bye-bye.